All right, I guess it's about that time, so we'll go ahead and start. Are there any questions before we get going? All right, so hearing none, so we're now in section 2 of chapter 3, and this is dealing with quadratic functions. Now, something to note is after we finish this section, I'm going to put up a homework assignment, and it's going to be a Word document. And so you'll need to download the document, answer the questions, and then re-upload it and submit it for a grade. And the key is it's really for statistics at the college. And so basically, if you turn it in, that's your grade. You're going to get 100% on it, basically. But really, I want you to work and think about it and do as well as possible, because it'll kind of help me understand what you understand about the quadratic function, things like the vertex, all the stuff we're going to talk about today. So it's going to be basically free points, but you really need to try to do it, and because it's going to go to a committee who's going to grade it, but it's going to be on the outside, not in the math department. So it doesn't affect your grade as far as the class goes, but it's going to affect on what they think you're learning in the classes. So that's something that's going to show up after we finish this section.
Do we need to show our work on that?
Yeah, so type out your work. Maybe if you have to, I don't know how it's going to work, because it's, if you can scan a document and put it back in, that would be great. Or if you can do the work on there, and a lot of people have like the tablets or something, you can use your finger or a pen and write on it, so you can do that in Word. And so do it that way, or whatever kind of works for you. Or if you want to, you can download it and then upload it back as a PDF file. But I would say when you upload it, either have it as a Word document or a PDF file. That way it's something that they can do something with. And it might be better if you want, go ahead and even convert your Word document to a PDF, and then when they extract those assignments on their side, because they're going to take it straight out of Moodle, then they'll have it, and it'll be theirs. So
Okay, thank you.
mhm. All right, so what we're going to deal with quadratic functions is basically parabolas. And so let's look at the different parts of a parabolic graph. We've kind of talked about a lot of this already. So much of what we're doing today is going to be kind of refresher, but some of it's going to be putting a different spin on stuff. And so we need to kind of talk about everything. And so what we have is we have a vertex. That's our extreme point, whether you have the max or min. Basically, it's where the graph changes direction. So if we look at the one drawn here, it's coming down, and then at the vertex, it switches directions and goes back up again. And so at this one's going to have a minimum. If we had one where it was inverted and opening down, that would give us a maximum. And so depending on your A, you'll have a minimum or a maximum vertex. Then we have an axis of symmetry, and that's basically the vertical line drawn through the vertex and makes the graph symmetric about that line. So if I had drawn this nice and symmetric, this we could just lay over onto this side, and basically you would have the symmetry on both sides. You could lay it and cut it in half and fold it in half, and it'd be there. Then we have our x-intercepts. Now we don't always have x-intercepts. So if we had a parabola that started up here in the the second quadrant and it was above the line, we would never have an x-intercept. Or if we were going down below, we wouldn't have an x-intercept. But if it does cross the line, the x-intercepts are those 2 points where it does cross the x-axis. And they're going to represent the zeros or roots of the quadratic function of x, where y is equal to 0. Because if we think about that, that's where y is equal to 0, and wherever it crosses there, those are our zeros, or the roots of the quadratic function. Then if we have a y-intercept, that's going to be where the point crosses the y-axis. So in this case, we have one right here, and that's where the x is equal to 0. So we don't have any going left or right for x. It's just right there. And so those are kind of the key pieces of a parabolic graph, and it's going to be things that we're going to use and we're going to solve for on some of the different things as we move through here. And our general form of the quadratic formula. So you kind of be good to remember general form and standard form. Those are going to be the two main forms that we're going to look at for the quadratic function. And so with the general form, we just have ax squared plus bx plus c. And the A, B, and C are going to be useful in this form to get several things. We're going to get our H and K, which is our vertex. We can get, we can solve for X using our quadratic formula. So there's a lot of things we can get from this formula. So it's useful to have it in this formula at some times. So in this formula, A, B, and C are going to be real numbers, and A cannot be equal to 0 because if it is, then it's not a quadratic. We won't have the X squared term. Okay. So if A is greater than 0, it's going to open up. We're going to have a vertex is going to be the minimum. So that's going to be what this is. This is opening up. Our vertex is down here. So we're going to have a minimum. Now, if A is less than 0, it's going to open down, and our vertex is going to be a maximum. Now, the axis of symmetry is going to be defined by x equals, and we have this minus b over 2a. And so this point here, the x value is a minus b over 2a, basically. And so we're just going to plug in b here, a here, solve that, and that's going to be our axis of symmetry line. And if we want to solve quadratics, there's going to be 3 different ways we're going to do it in the class. One of them, this is this old standby that everybody knows, the minus b plus or minus the b squared minus 4ac over 2a. So that's the one that we can use no matter what the a, b, and c are, and we don't have to worry about factoring. We don't have to worry about putting it into standard form and then solving. This one works every time. Then we have a standard form of the quadratic function. It's also known as the vertex form because we have our h and our k, which is our vertex. And so in this form, it's a times the quantity x minus h squared plus k. And we can get our h by taking minus b over 2a. So if we initially had our general form, we could find h, and then we could find k by plugging in our h into the original general form and get the k value, and then we could go to this form here. So it's not hard to go from our general form to our standard form. All we have to do is know our a and b basically, and then we can get the h, then we plug in whatever value that is, say it's a 3, then we can plug that back into our original equation, and then we can solve and we can get what f of whatever that h was, and then that would be our k, and then we can plug those in here where a's from the original equation, it's the same a, then we just take x minus whatever our h was, that quantity squared, plus our k, and we could write it into standard form. So we can go basically back and forth between standard and general using the h and k features here. Now remember, in this form here, basically we have all the different transformations. So our k, it shifts it up or down, our parabola, and h shifts it left or right, and then the a is going to stretch or compress it depending on which way it is. And so this is something we've been looking at on the last test. We have a lot of those transformations, and so it's not going to be any different than now, but a lot of times what we're going to do is we're going to have like a graph that's already drawn, and we have to put it into this equation, and so our transformations are going to really help us to get it in from a graph into a standard form. And this is really how we're going to do it. So given the graph of some quadratic function, so say, this example here, and what we're going to do is we're going to work that. We can write the general equation of the function using our knowledge of transformations. So first we're going to identify our horizontal shift, which is our h. Then we're going to identify our vertical shift, which is our k. Then we can substitute those values, our h and k, into our standard form. Now what we're going to do is substitute a value for x and y for any point on the graph except for the vertex. So maybe, you choose where the y-intercept is, or maybe one of the x-intercepts, something that's easy to find on the graph, and you plug that into this equation here. And so the f of x will be your y, and then your x is going to be whatever it is on here. And then we're going to solve for a. So we'll have, our y, we'll have x, we'll have our h, we'll have our k. All we have to do is solve for a. Once we have that, we can plug it back in. And now remember, if a is greater than 0, it opens up. So if you're getting a that's not, greater than 0, then you've done something wrong. And a less than 0 opens down. So if you're going to get a graph something like that, better have an a less than 0. And then basically we add that a back into the quadratic function, put our x back in and our f of x back in. And then we basically square whatever this is, take it times the a, add whatever the k is, and then we write it into general form. So then we're going to get it into some ax squared plus bx plus c. So let's look at that for this example here. And what we have is we're going to have, we need to find all the different pieces. If I find my mouse, there we go. And so we need to find what is that vertex. Well, that vertex is a -1, 2. So our vertex is a -1, 2. Now we need another point. We need some xy. So I think I'm going to use this one just because it crosses, right there at the 0, 3. So I'm going to use the xy equal to 0, 3. And now I'm just going to plug all of that into the standard form, and then I'm going to solve for my a. So when I do that, I'm going to have y, which is 3, equals a times x, we said was 0, minus h. Well, h was the -1, so minus a -1 is going to be minus 1 is plus 1, quantity squared, plus k, which is the 2. Now we simplify here, so that's 3 equals, and then this is 1 squared, so it's 1, so it's a, and then plus 2. So if we subtract 2, that's 1 is equal to a. All right, so that's going to be our a value. Now we can plug that back into our standard form with our h and our k, and so that gives us f of x equals 1, or we can just leave it off, times x plus 1, the quantity squared, and then plus our k, which is 2. Now we have to square this because we're going to the general form. So if we square that, that's going to be x squared plus 2x plus 1. And we still have plus 2 here. And so that's x squared plus 2x plus 3. And so that's going to be our function in the general form. And if we needed it to be, we have our standard form here as well. So we have both forms when we get to our general form. We've already had to put it into standard form, then we expanded it and simplified it to get to our general form. And so that's what we're going to be looking for when we go from some graph to some quadratic function. Okay. And again, it's just picking your vertex. That's the first thing you need to do, and then some other point. We could have chosen this point here if we were really sure it went from -3, 6. We could plug that in. We should get the same thing as far as our final a goes. And then when we plug that in here, everything is going to work out the same there. So that's what we're going to do when we go from given a graph of some quadratic function going to writing the general equation. So any questions there? And I'll do another example on a supplemental video, so we have some extra examples of most of these things we're going to work on today. All right, so here we're going to be given a quadratic function in general form. So, the ax squared plus bx plus c. And what we need to do is we need to find the vertex, and then we're going to go and we're going to write it in standard form. So what we're doing is really playing around, going from general to standard, standard to general, and using all the a, b, and c values to get to each direction. So what we need to do is once we have our quadratic function in general form, we need to know what our a, b, and c are. And then we have to start with finding what is h. Well, h basically is just the minus b over 2a. So we just plug in whatever our b was, and we plug in whatever our a was, and we get a value for h. Then we have to solve for k by plugging in whatever that h is into our original quadratic function. So we're going to plug in f of h, and so that's whatever that value was. And that's going to give us a k value out. Then our original function had a already, so we'll have the a, we'll have the h, we'll have the k, and so we can plug all of those into here, and we have our standard form. So we get our a from original equation, our h we got from the minus b over 2a, and our k we got from plugging that h into our function. And so what we're going to do is we're going to do an example here. And sometimes they're going to give you your function and it's not going to be in quote standard form, because really this should be x squared minus 6x plus 13. That way we have a, b, c. Here it's c, a, b. And if you're just looking at it and you write 13 down as a, you're going to get the wrong answers. All right, so what are we going to do first? Well, we have to find what is h. Okay, well, h is going to be a minus b, which is a minus 6, all over 2 times a, which is 1. And so minus a minus 6 is 6 over 2, and so that gives us a 3. Now what we do is we take that 3 and we have f of 3, so, or in this case g of 3. So g of 3 is equal to, and that's going to be 3 squared minus 6 times 3 plus 13. So that's going to be 9 minus 18 plus 13. And so that looks to be, that's going to be a minus 5. That's going to be a 4. Okay. Oh, yeah, 4. All right. So we know now we have h and we have k. So the vertex is equal to 3, 4. All right. And we know a was 1. So now we can put it into standard form. G of x is equal to, and now we just have a, which is 1, times x minus our h, which is 3, the quantity squared, plus k, which was 4. And though that there is the standard form. Okay, so we start with the general, and then we move to the standard. Okay. Any questions on that one? Again, a lot of this is pretty easy stuff. You just have to plug in values A, B, and C, and use your calculator if you need to get the actual numbers, because some of them will get to be big numbers. You have to have a lot of calculator usage, I think, on some of the sections. But this is something that's not too hard to do as long as you plug it in correctly into your calculator. All right, so a couple more things with parabolas. We can find the domain and range. So really, it's kind of nice because our domain of any quadratic function is going to be all real numbers. And if you think about it, if you have your parabola going down like this, you know, it's just going to keep going in each direction. So your x's are going to be all of them. Or if you're going up, no matter what, that's going to keep going this direction, that's going to keep going that direction, and so it's going to be all the x's. So your domain is always going to be all real numbers. So no hard stuff there. Now we can get the range pretty easily. If we have the general form, what we do is we look at our, ax squared plus bx plus c, and the range is going to be if a is greater than 0, basically we're going to have a minimum, we know. And so that means our parabola is going to be like this. We're going to have some kind of minimum. So we know that's going to be whatever that value is, it's going to be the lowest, and it's only going to go up from there. And it's going to go up to positive infinity. And so, well, what is that value? Well, f of x is going to be greater than or equal to f of the h, or minus b over 2a. So whatever that is, you just plug that in and then plug it into your formula, and then it's going to be basically your bracket on the left, then whatever that value is plugged into your equation, comma, positive infinity. And that's when a is greater than 0 because you have the minimum. Now, if your a is less than 0, that means we're going to have a parabola going down, so it's going to have a maximum value. And so basically, your range is going to be everything below that. So it's going to go from negative infinity all the way up to whatever your maximum value is. So your f of x, or your y, is going to be less than or equal to f of, and here again, that's your h value. And so you plug that in, and that's once you plug it in, that becomes k. So it's going to go from negative infinity up to whatever your k value is, the y value. And then you have your in bracket. So that's going to be included because that point's included on your graph. It's not like a open circle at that point. It's actually a closed circle. So it's going to be included. And that's why we have a bracket on the right side here as the maximum and on the left side here as the minimum. So that's if you have general form. If you have standard form, it's a lot easier to think about because you should already have it in this format here. And so really, we just have to look at what is that k value. So when we have a greater than 0, we know it's a minimum. So it's going to go from that k value, whatever it is, up to positive infinity. And if it's less than 0, well, then it's going to go from negative infinity up to that k value, and then it's going to be the bracket. So both of these basically are saying the same thing because this here piece is just k, and again, this is just k, but because it's not in the form of standard form, we think of it as f of the h or f of minus v over 2a. And the same thing here. This is also, your k, and this is also your k. So that's why we have just from k to infinity or from negative infinity up to that k. Okay, so let's look at some, let's see, make sure I have the thing. Yeah, let's look at some finding domains and ranges. So we'll do one where we have a standard form, and we'll do one where we have the general form. All right, so our domain, well, we already know that. That's going to be all real numbers. And so we can say that's all real numbers there as well. And so we've got those, we know those pretty easily. All right, so what do we have here? Well, remember, here we have a is 2, and if we need to, we can go back in to say, oh, a is 2, that's going to be, greater than 0, so it's a minimum. So I'm going to go from whatever k is up to positive infinity. Okay, well, what is k? Well, k is 8/11ths. So I'm going to go from 8/11ths up to positive infinity, and that's going to be my range. So this is the easy one because k is already given to you. Now the next one, we have to do a little work to get to k. So we have a, b, and c. So first we have to find h. Well, h is a minus 4 over 2 times 2. Well, that's going to be a plus 4 over 4. So that's just going to give us 1. So that's our h. Now we have to solve for k. Well, k, we just plug in 1 into our equation here. So that's going to be 2 times 1 squared minus 4 times 1 plus 2. Well, when we solve all that down, it's going to be 2 plus 2 is 4 minus 4, so that's 0. Okay, so that's going to be our value. Again, we have a is positive 2, so it's going to be going from whatever our k value was, in this case 0. So we're going to go from 0 all the way up to positive infinity. Now, if this had, say, been a negative, then it would go from negative infinity up to 0, and then we'd have our bracket. But we probably wouldn't still get a 0, though, if we had a negative 2 here. But just in case it had been, you would just have that backwards there. It'd go from negative infinity up to that 0. And so that's how you find the domain and ranges on different types of functions, whether they're in the standard form or they're in the general form. Okay, any questions there? All right, so now we're going to look at a few more things. We're going to determine several different things. And the last three, we're going to determine the same thing. We're looking for x, but there's 3 different ways we can find x. And so that's why we have 3 different spaces here, but it's all looking for x is what it is. So the first thing we're going to do is determine the minimum and maximum values of a function. And basically, we're looking at our vertex again. So if we're given the general or the standard form, we're looking for that vertex hk, okay? And so again, if a is greater than 0, it's going to be a minimum, and the value k, it's going to be a minimum value k when x is equal to h. So that's going to be our minimum at the x equals h. Now, if a was less than 0, we're going to get a maximum value at k when x is equal to h. So that will be a maximum when a is less than 0, and then it's at the x equals h value. Now, how do we determine x and y intercepts? Well, if we have the general formula and it's factorable, that's the key here, Then basically to find the y-intercept, we just plug in 0 for x and solve for y. And that's going to give us what it is. And so that one's pretty easy, just plugging in 0. Basically, if you have the general form, it's going to be whatever that plus or minus whatever that last value is, because if you have the x squared and the x, those are going to go to 0, and it's just going to be that last term. Then after that, we need to solve the quadratic function f of x equals 0. So we're going to set the whole quadratic function equal to 0. Then we have to factor it, and then we use the 0 product rule, and that'll give us our 2 x-intercepts if they're truly going to be intercepts there, and that'll give us what our x values are. Now, if it's not factorable very well, and some cases that's the case, what we can do is we can determine the x-intercepts by first rewriting in standard form. Okay, so how do we do that? Well, we substitute a and b into h equals minus b over 2a like we've been doing. We substitute h equals k into the general formula and solve for k. Then we rewrite in standard form using a, h, and k. And then the key difference here is once we have it into the g of x equals a times x minus h squared plus k, what we're going to do is we're going to set this part equal to 0, and we're going to solve. So then we're going to take the k over, and then we're going to divide by the a, and then we're going to have take square roots of both sides, then we're going to add the h, and so it's going to be a little more complex, but we can still solve this one easier than trying to factor one that's hard to factor. So this is the one where if it's kind of hard to factor, we'll do it this way. And then sometimes it's just even doing it this way makes it really hard. And so we're going to just do the plain old quadratic formula. And the minus b plus or minus the square root of the b squared minus 4ac over 2a. And so what we're going to do now is we're going to do some examples where we determine the minimum and maximum, or whichever one it is, depending on a. And then we're going to go through this different steps on how to solve for the x's and y-intercepts. So our first one is going to be this. F of x equals 2x squared plus 10x plus 12. All right, so what do we need to do? Well, we first are going to find, if I can find my thing, f of 0. Okay, well, what's that equal to? Well, if we plug in 0 here, that's 0. Plug in 0 here, that's 0. So that just is equal to 12. Okay, so our y-intercept is equal to 0, 12. Okay. Let's think about domain and range, because that's something we can do pretty easy. The domain is going to be equal to, well, it's going to be all real numbers. And our range, well, before we can get that, we have to find our h's and our k's and things like that. So what we have is, let's say we have h is equal to a minus b, which is 10 over 2 times a, which is 2. So it's going to be a minus 10 over 4. And so that's going to be a minus 5 halves. All right, so that's our h. Now our k, so now we have to plug that minus 5 halves into all of those places. So that's going to be 2 times minus 5 halves squared plus 10 times minus 5 halves, and then plus 12. And so if we plug all that into our calculator, let's see what that equals. That's 2 times negative 5 divided by 2 squared plus 10 times negative 5 divided by 2 plus 12. That equals a negative 1/2. Now, where's my thing? All right, so that's our k. So we know then our vertex is equal to negative 5 halves. Where's my negative didn't write there. Okay, negative 1/2. All right, so that's our vertex. Okay, with that we can get our axis of symmetry right away, because axis of symmetry is just what x is. So that's x equals negative 5 halves, and that's the axis of symmetry. Let's see, now let's go back over and put our range in. So our range then is going to be, well, remember, where did our range go? Our range, if our a was greater than 0, then it's going to be just the k comma infinity. And if it was less than 0, it's negative infinity to that. And so since a is greater than 0, we just put k, k, which was the negative 1/2, up to the infinity. So that would be our range. So that's going to be our minimum, basically. And I guess if we need to find the min is negative 1/2 at x equals negative 5/2. So we found that. We found the min. We found the y-intercept. And now what we're looking for is the x-intercept. All right, and again, I'm just kind of doing things as I think about what we're working on. And so then the last thing we're going to do is we're going to say, okay, well, 0 equals 2x squared plus 10x plus 12. Now I can factor out a 2 here, so that's 2 times x squared plus 5x plus 6. Now if I divide by 2, then I just have 0 equals x squared plus 5x plus 6. And then I can factor this 2 and 3, so x plus 2, x plus 3. And so using a zero product rule that says x is equal to a minus 2 or x equals a minus 3. And so my x-intercepts are going to be a minus 2 comma 0 and a minus 3 comma 0. Now, since these were so easy, I'm not going to do the other two ways to do this because, you know, the first one, if it works, you don't have to do the other two. But if we had one that wasn't nicely factorable, then I would do the other two ways as well. All right, so I think we have everything now. We have the x-intercepts, we have the y-intercept, we have the min, we have the domain, the range, and the axis of symmetry, which we got from the vertex. Okay, so any questions on anything there? There's a lot of stuff, but again, nothing super hard as far as math goes. It's just kind of remembering everything as far as what you need to do. All right, so let's do another one. H of t equals negative 4t squared plus 6t minus 1. We want to find all those same things again. We want to find the min, max, axis of symmetry, domain, range, x and y intercepts. All right, so our first thing we could do is we could say, well, what is h of 0? Well, h of 0 is that's 0, that's 0, that's negative 1. So our y-intercept is equal to 0, negative 1. Now, if we go along the same thing we did last time, the domain, that's all real numbers. And our range, well, this time we have a negative here. So we know we're going to go from negative infinity up to some value. So that's what we have to find this time. And so h is equal to, well, we have a minus 6 over 2 times a minus 4. Well, the minus and the minus cancel, so that's going to give us a positive. And 6 over 8, so that's going to be 3 over 4. So that's our h, is 3/4. Now we need to find what h of 3/4 is. So k equals negative 4 times 3/4 squared, and then plus 6 times 3/4, and then minus 1. If we plug all that into our calculator, minus 4 times 3 divided by 4 squared, and then plus 6 times 3 divided by 4, and then minus 1, and we get 5/4. So k equals 5/4. So that means our vertex is going to be 3/4, 5/4. And that's going to be a max of 5/4 at x equals 3/4. So that's our y value. So the max is going to be a y equals 5/4 at that x equals 3/4. And so that's also going to be where the max is for our range. It's going to go from negative infinity all the way up to that 5/4, and then we include that 5/4. All right, and because of this, we also know the axis of symmetry is equal to, or is x equals 3/4. Okay. Now, the only thing left we have to do then, I think if I remember the main range, that is going to be find our zeros or the x-intercepts. Okay. Looking at that, I don't see a nice way to factor it. So the first way to do this, where you'd use a zero product rule after you factor, that's not going to work here. And so basically, I'm going to skip to the second one, and then I'll do the third one to kind of show you how it's just easy to plug in the values into the quadratic formula. On the second one, what we have to do is we first have to write it into standard form. So h of t equals, well, we have our a, which is a -4, times x, and minus h, which we found was 3/4, that squared, and then plus k, which is 5/4. And so now we have it in standard form. Now with standard form, it says, we say, okay, that's equal to 0 now. So instead of factoring, we put it into standard form and solve for x. All right. So we're going to subtract 5/4 from both sides. And so we have a -5/4 equals a -4 times x minus 3/4 squared. So now we're going to divide by -4, which is the same thing as multiplying by -1/4. And so that gives us 5/16 equals x minus 3/4, the quantity squared. Now to get rid of that squared term here, what we need to do is take the square root of that. And so what we need to do is take plus or minus the square root of that. Now nicely, the denominator is the square root, it's a perfect square. So that gives us a 4 in the denominator. Our numerator still is just a square root of 5, and it's plus or minus, and that equals x minus 3/4. Okay. So now, now the last step is add 3/4 to both sides. And so then we get x equals the 3/4 plus or minus square root of 5/4. Okay. And because we have the radical there, I'm just going to leave it in this kind of form here. If we wanted to put it as one fraction, we could have 3 plus or minus square root of 5/4. But if we have it like this will kind of get us ready to look at values when we have i's in them. So we'll just leave it like this. And so our two x-intercepts are going to be 3/4 plus square root of 5/4 comma 0, and 3/4 minus square root of 5/4 comma 0. And those are the x-intercepts. Okay. So if we actually graphed this on like Desmos or something like that, we could actually click on each of the x-intercepts, and if we multiplied this out and did the division and added, subtracted, or whatever, we would see that does equal the actual points on the Desmos graph. It's going to have a decimal out to however many decimal places, and it's going to be something different, but this is going to be the exact value, and that's what they're going to ask for a lot of times, is the exact values. All right, so that's the way we can do it with the standard form, and we can also do it the other way, where we have x equals a minus b, which is 6, plus or minus the square root of b squared, which is 36, minus 4 times a minus 4 times the c, which is a -1, all over 2 times a minus 4. Okay, so simplifying that, we have a -6 plus or minus a square root. Well, 36, and that's going to be 16, but it's going to be negative. That's going to be square root of 20 all over, and this is going to be a -8. All right, well, 20, if you think about that, square root of 20, that's equal to the square root of 4 times the square root of 5, and the square root of 4 is 2. square root of 5. And so what we can do is we can write this as -6 plus or minus 2 square root of 5 all over -8. Now, if we split it into two fractions, kind of like we did here, that gives us a -6 over a -8 plus or minus, and then we have 2 square root of 5 over a -8. Now we can reduce, and that gives us just a 3/4. Now, when you take a minus with a plus, that becomes a negative. And when you take a minus with a negative, it's plus. So we still have plus or minus. And then the 2 will cancel here, and 2 will cancel here, and we have 4. So that's the square root of 5 over 4. And so we get the same thing as we have here. We just had to do some more simplification with the quadratic formula. So again, this way gets you the answer, and this way gets you the answer as well. It just depends on, which one you want to do. Sometimes they'll ask you, well, I should say, sometimes I'll ask you on the test to do it both ways. Sometimes I'll say just do it whichever way you find the best. So as long as you know how to do it one of the ways, then that'll work. Okay. Any questions on that one? I'll do another example on the extra video as well. All right, the next thing we're gonna do is solving equations over the complex numbers. And what happens when we have complex numbers is, if you notice this, x squared equals -25, that means we wanna have an imaginary number for our answer. So when we have complex numbers, we're gonna have imaginary numbers. And so if we think about that, well, how do we solve that? Well, we just take the square root of both sides. So we're going to take the square root of x squared equals, and then we have plus or minus the square root of -25. Well, square root of -1 is I, square root of 25 is 5, so x equals plus or minus 5i. Okay, and that would be one way to do this. Now, another way to be doing this is what you'd have to do in the case of this second one here. And what we would do is we would rewrite this as x squared plus 25 equals 0. So basically, we add 25 to both sides. Now we have an a, we have a c, there's no b, and we can use our quadratic formula again. So that's going to be a minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that just is 0. And then we have plus or minus the square root. Well, here we have 4 times 25, so that's 100. So that's going to be a minus 100 all over 2. Well, square root of -1 is I. Square root of 100 is 10. So that's going to give us plus or minus 10i over 2, which reduces to plus or minus 5i. So we get the same thing. This one was a lot quicker, but the second way is going to be the case which you have to do a lot of times when you have something with all three values instead of, just something like x squared equals this. That's easy. Take square root of both sides, you're done. You have plus or minus this 5i. All right, so let's do this one. And again, because we can't just say, square root both sides, what we have to do is we have to plug it in. So x is going to be a minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that gives us a minus 8 rather, plus or minus the square root, and that's going to be 64 minus, and that's going to give us 100, and then all over 2. Now this is going to give us minus 8 plus or minus the square root of a -36 all over 2. Now this is going to give us 6i because the square root of 36 is 6. Square root of -1 is I, so that's going to be a minus 8 plus or minus 6i all over 2. And so what we have to do is we have to, break this apart into the real and imaginaries. And so it's going to be a minus 8 over 2 plus or minus 6i over 2. So it's going to be a minus 4 plus or minus 3i. And so that then would be our answer for what x is equal to. Okay. And again, it's just using the quadratic formula, plug everything in, remembering that this one asks you to do the complex numbers. And so a complex number is going to be that plus that. Now, if we really wanted the complex number instead of just the imaginary number, you know, we'd put the 0 plus or minus the 5i here to make it the fully complex. But, you know, when you do this, a lot of times those zeros just drop and we just keep the imaginary number only. All right, any questions on that one? All right, so the next thing we're going to do is be given a vertex and a point on a graph, and then we want to find the general form of the quadratic function. So kind of the similar stuff of if you had a graph and you pulled these points off, can you actually just do it? And so it's the same thing we've done before, and now we're just going to implement it when we're just given this instead of an actual graph. So what do? Well, first off, we have to figure out, you know, what is our equation. And if you remember, it's y equals a times x minus h, the quantity squared, plus k, in the form where we have x, y's, h's, and k's only. And we have to solve for a. All right, so y is 3 equals a times x, which is a minus 4, minus h, which is going to be a minus 2, and that's squared, plus k, which is a negative 1. All right. So simplifying that, we have 3 equals a times, here we have a minus 4 plus 2, so that's a minus 2 squared, so that's going to be 4. And so then that's going to be minus 1, so if we add 1, we have 4 equals 4a, so a equals 1. So now we know that. We can plug everything back into this and say f of x, I don't know what the actual function is, but we're going to call it f. F of x equals a, which is 1 times x. And then as a minus 2, so plus 2 squared and then minus 1. That's going to be our standard form. And they want the general form, so we have to square this. So that's going to be x squared plus 4x plus 4 minus 1. And that's going to give us x squared plus 4x plus 3. That's f of x. And so that's going to be our general form. Okay. And again, we've done that already at the very beginning when we were doing it straight off a graph, but this is kind of how another one of the examples in the chapter has you doing it with these instead. All right, so now we're done with all the things like that, so it's application time. And so the applications really aren't too bad. You kind of have to think about some of them to see what they're asking for and what you can get. And others, you know, they're just there. And so I'll do maybe 1 or 2, and then the rest of them I'll do in the extra video, so then you can have those also. So it says, find the dimensions of the rectangular corral split into 2 pens of the same size, producing the greatest possible enclosed area given 300 feet of fencing. All right, so we're going to have some kind of a rectangle corral. And we're going to split it in 2. And we have to fence all the pieces. So we're going to have this fence, this fence, this fence, that whole fence there, and that whole fence there. And so if we say x is going to be that value, that means that's also x, and that's also x. And then for simplicity, let's say that whole length over there is y. That way we don't have to say y over 2 and y over 2. We can just say, you know, the whole thing. And then when we get done, we're going to take, you know, x times y to find out what the whole area of the enclosure is. But what we need to do now is figure out based on the total amount of fencing we have here. So what do we have? We have 1, 2, 3 x's. So that's going to be that much fencing, plus 1, 2 y's. And that's a total of 300. That's all we're allowed. And we know that the area is just x times y. Okay. Now, what I'm going to do is I'm going to solve our first equation here for either x or y. It doesn't matter which. And then I'm going to plug that into the other equation and go from there to get my quadratic. And so maybe I'll do is I'll solve it for y just because it looks like it'd be a little nicer. So if I take the 3x to the other side, we get 2y equals negative 3x plus 300. Now if I divide by 2, y equals a negative 3 over 2x plus 150. So that's what y equals. And so what I'm going to do now is plug that into my area. And so that's going to give me a quadratic. So I'm going to say maybe that's a of x equals x times negative 3 halves x plus 150. Again, just plugging in the y here, which is that whole part. Now, if I multiply that, that's a negative 3 halves x squared plus 150x. Okay. So what do we know? Well, we know because here a is less than 0 that the vertex is going to be a max. And that's kind of what we want because we want the greatest possible area enclosed. And so that means once we get that vertex, that's going to give us that maximum value. So we need to find what is h. Oops, let's just erase here. All right, so h. Well, that's minus b over to 2a. Well, that's the b and that's the a. So it's going to be a minus 150 over 2 times negative 3 over 2. Well, those 2's cancel, and 3 goes into 150 50 times, and then negative over negative is positive. So that gives me a 50. Okay, so that really is my x coordinate. Okay. Now, if I plug in that x coordinate into an equation here, I can solve for y. So if I say y is equal to minus 3 halves times our 50 plus our 150, well, if I plug that into the calculator, that gives me negative 1.5 times 50 plus 150. So that's giving me 75. And so that's equal to y. And so that should be my dimensions. My dimension should be, and this is in what's their units? Feet. Okay. So this is feet. And so this should be feet. And so it looks like my area is going to be 75 by 50. So the area is going to be 75 by 50, which is going to give me 3750 square feet. Okay. So that's my area just using the x's and the y's. And another way we could have found that area is we could have taken our h here and plugged it into our area formula here, and we could have got out the same thing. So if we did that, we're basically looking for k. Well, that's going to be negative 3 halves times the 50 squared plus 150 times 50. And if we plug all that together, we still get 3750, and that's going to be feet squared. So our x is equal to 50 feet, and our y is equal to 75 feet. Now, does that work for our equation? Well, 3 times 50 plus 2 times 75, that's equal to 300. And x times y is going to give us our total area. And so that looks like we have our answer to that one. Okay, any questions? All right, let's do another one. So here it says, suppose that the price per unit in dollars of a cell phone production is modeled by P equals $45 minus 0.0125x, where x is in thousands of phones produced, and the revenue represented by thousands of dollars is R equals x times P. We want to find the production level that will maximize our revenues. All right. Well, if we have that, what we can do is we have a P value, and we can plug that into our revenue, and then we have everything in terms of x. We'll get a x squared value, so we'll get our quadratic, and then we can start seeing what that gives us. So x times, now we just plug in this. So that's our production times our x, which is a number of phones produced. And so if we do that, that's going to be 45x minus 0. That's a 0.125. And then that's going to be x squared. And so if we write that in the conventional form, it's going to be a negative 0.0125x squared plus 45x. So that's our A, that's our B. Now, because again, that's a negative, that means we're going to have a maximum value. So whatever we find for our H and K, for our vertex, that's going to give us a max. And so if we look for our H, that's going to be a minus B, which was 45, over 2 times A, which is a negative 0.0125. And if we plug that into our calculator, we should get 1,800, and that's going to be thousands of phones. Okay. And if they ask for, that's the production level that will maximize the revenue. So that's our answer for the question. But it doesn't say what is going to be our revenue, but we could find our revenue by finding K. And so we just plug in that number there into our value over here. And so if we do that, that's going to be negative 0.0125 times 1,800 squared, and then plus 45 times 1,800. And if we get that, that's going to be 4,500. Okay, and so that will be our maximized revenue for that many thousands of phones. Okay. So those are pretty easy. They're usually set up so you just have to plug in one of the values into the other equation here. We don't actually have to come up with our own equations because they're, you know, revenue models, and so they'll come up with the models for you. Now, the last one I want to do before we go today is one that's going to be similar to what's on the sheet I'm going to upload here in a little bit to Moodle. And so this one is a ball is thrown in the air from the top of a building. Its height in meters above ground as a function of time in seconds is given by this equation. H of t is equal to negative 4.9 t squared plus 24t plus 8. And wants to know how long does it take to reach the maximum height. All right, so what does that give us? Well, to reach the maximum height, that's going to be our h. And so we just have to plug in our A and B, and we'll know what our H is. So that's going to give us a minus 24 all over 2 times negative 4.9. And if we plug that in, that's going to give us approximately 2.449. And that's going to be seconds. So that's going to be actually our value as far as when it reaches that maximum height. Now it doesn't ask for it, but what we could do is we could plug in and find out what the maximum height is, and all we'd have to do is plug in for K. And so K is equal to, and then we just take negative 4.99 times 2.449 squared plus 294 times 2.449, and then plus 8. And if we do all that in our calculator, we should get about 37.388, and that's going to be in meters. And again, they don't ask for that, but that's going to be the maximum height at that time in seconds. And so if you think about it, you're going to throw a ball up, it's going to go up, and it's going to come down. Now, if you're holding it in your hand, it's probably going to start at a higher value than at the 0. And so it's going to go up to this point here. That's your vertex, which is the 2.449, comma 37.388. And so that's going to be your time. That's going to be your height. And then eventually it's going to come down over here and hit the ground. And that's going to be at height at time, or height at 0. And you'll have to find your own time. All right, so that's all I have for today. Again, tomorrow the exam. So I'll see you again at 1 o'clock at the same time. Be sure you have your video and audio on, and then we'll be able to take the exam. So see you then.